Greetings and welcome. We're taking a look at our homework on page 915. Yesterday we were talking about measures of variability. We talked about the range, we talked about the interquartile range, we talked about quartiles, box and whiskers, semi-interquartile range, outliers, and eventually we hit mean deviation. And problem 15, let me read the directions here if I can find them, specifically said, find the mean deviation and standard deviation of each set of data. Standard deviation we'll save for later today, but in order to do that, we actually had constructed a little Excel spreadsheet. I've got some friends here. Hi, friends. And I had it set up where we could enter the data over here, and it would calculate the mean deviation for us. So let's see. Actually, before we do that, let's see if we can remember what the formula for mean deviation was. So mean deviation, if I recall, was the 1 over n. Let's see, it was described as being the average distance that our points were from the mean. So it was 1 over n times the sigma of I equals 1 to n, right? In which I had taken my data points, xi, subtracted the mean, so that is a difference, and the average of the differences we talked about would be 0. But if I absolute value that difference, that becomes a distance, because distance is always positive, and the average of those distances, all right, will describe kind of how spread out our data is. If it's a very low average distance from the mean, then that means my data is very clustered towards the center. If it's a high average distance from the mean, then that means it's super spread out, right? So that's kind of the concept that is at play here. Let's see. Right, there we are. So here is this, and let me actually, I've also got this data pre-entered in over here. I'm going to copy it and paste it, so that way we don't have to see me enter in a bunch of numbers. And it's thinking, it's working, bam. All right, so what I've done is I've entered this list of data. Actually, if we want, we could even sort it. I think sort column A to Z. No, that's not what I would have wanted to do. Is there not a quick sort on this? Sort the range. Aha, so I don't want to sort the whole sheet. I just want to sort that. There we go. So sorts it from least to greatest, if that was helpful to us. And let's analyze what's going on here. Actually, can I change the view, the zoom on this? Because this might be too small for my internet friends that are watching. Sadly, I don't think there's a nice zoom option on this like there is in Excel. Unfortunately. Well, let me grab a snapshot of this nonetheless, and then I'll analyze it from my notebook. Handy dandy. So here we are. Oh wow, look at, there's all our friends. Wow. It almost says one of your names there, but it doesn't, so you're safe. The internet won't stalk you. As far as they know, Ito is one of our students here. So let's see, we had 12 data points. Here's the data. It found the mean of that data, all right? So that would be my X bar column. I could, right? Notice I even refer to it as X bar in the spreadsheet. And then it finds the difference of my data point from X bar. So 369 minus 403.5 is a negative 34.5, and it finds all of these distances. If I averaged these distances, it would be 0. But then I take the absolute value of those differences, and I get a distance, and I add those up and divide by 12, and that's where I get the mean deviation of 20.25. So the mean deviation for this problem is 20.25. Now, I can't just be like, well, 20.25 is a bigger mean deviation than another problem I looked at, so therefore this is really spread out data. I actually have to kind of consider it in terms of looking at the scale or the size of my data, right? My mean was 403.5, right? So 20 in respect to 400, right, isn't a whole lot, right? If my mean deviation was like in the thousands and my mean was only in the 400, right, then I would say that must be way more spread out. But it gives me an idea. Eventually we'll actually get graphs kind of describing not the mean deviation but the standard deviation of a data's distribution, and that'll give us further insight on it. But at this point, all we were calculating was this number, right, compared to the mean. So kind of on average, my data is 20 units from that mean, right, is what that's saying. So let's scroll over here. And here is problem 23 later on in the lesson. It says, refer to the data on the college tuition fees and fees in the application at the beginning of the lesson. And so I've copied the data. Just closing the door here for us as best I can. So I've copied the data, and I've got it down there. And the tuition and fees is specifically the right-hand column. The enrollment wasn't what we were interested in. We were interested in the money. And by the way, sorry for those of you going to college in this, I guess, millennium. The prices are going to be way more expensive than this for you. Actually, just during the 4 years of college while I was there, the fees is what's tricky. Somehow they get this loophole. The fees at my college, I think, more than doubled in the 4 years I was there. So it's crazy. So that's sometimes hidden since it's not part of the tuition necessarily, that kind of front number that you might see. So let's see. It says, what are the quartile points of the data? Well, let's see. I think I could. I've got a list over here already written out. And let's see. So let me pull this on over here, and I'll zoom in to tell you what 175 seems like a fair scale for us. We'll throw this in normal view. Bam, there we go. Now our internet friends can see our list. So here's all of the values. If I'm interested in calculating kind of the median and such, it would be worth putting this list in order from least to greatest. So it says, what are the quartile points? So Q1, Q2, Q3. I guess I'll point out, let's see, Q2, Q1, and Q3. So Q2 is just going to be the median of this list. Let's see what Excel does. What Excel does with that. I got 2838, and that is this number right there, 2838. So that seems to be an agreement. Now, 2838 is this number right here. Okay? So do we agree that that's the middle number of our list? Okay? Well, how many values were in my list? I can count them. Or make Excel, actually there's 19 if I just looked right there, that's funny. 19. So since that's an odd number, then I would have had, oh man, my brain just blanked. I would have 9 in on the top half, 9 on the bottom half, and 1 number in the middle. So that right there is in fact going to be my quartile. Let's see, can I, borders and shading, maybe I'll highlight that somehow, like so, bam. Right? So there's my median. Now, if I want to find quartile 1, I'm actually interested in the median of just the first half of the data. Okay? So this would equal the median of these guys. And I get 2414. So there, yeah, so this is Q2 and median are one and the same. Yeah. So quartile 1 is the median of the first half, and Q3 is going to be the median of the second half of the data. Don't want to include that 19 there. And I get 4147. And we happen to be very lucky in how this worked out, where it ended up being kind of like all really nice for us in its arrangement. Now, if I had an even number of data points, then my median, all right, or Q2 would have been between two values, right? We've seen that before, I think. And I would have had to find the midpoint between them. When that occurs, the first value would be considered part of the first half, and the second value would be considered part of the second half. All right, just so you're aware when that does occur. All right, so I get for my values here. I've got those calculating. I'll just grab a little snapshot. That was a sad snapshot right there. So for part A, that's what I got, right? And let's see where this goes. I'm going to keep using Excel here, but doing this stuff by hand also works. Let's see, B, find the interquartile range. So let's pop back in Excel. Interquartile range, I guess I could refer to it that way. That's not an official symbol. But the interquartile range, do you guys remember what that is? Distance between, or yeah, the difference between Q3 and Q1, I guess it would always be positive, ends up being 1733. And that agrees right there. Name any outliers. Now, to find an outlier, I need to know what is 1.5 times the interquartile range, right? So I'm going to actually calculate that. I'll do 1.5, little star, by the way. The asterisk is used to, let me see if I can actually change this to like 185. Will I fit my whole list? Oh man, it's yelling at me. All right, stop it. Cut it out, Excel. I understand. All right, I'll finish my formula later. I got distracted halfway through. Would 200 fit? Yeah, there we go. So equals 1.5. Star is the multiplication symbol in most computer languages. So I'd multiply that by the interquartile range, and I get 2600. Now to find out where the outlier lower limit is, which I guess I could describe this way. And the higher limit, it has to be 1.5 times the interquartile range beyond the lower quartile, so less than this, or greater than the upper quartile, quartile 3, okay? So the lower quartile would be this minus that 1.5 times that. And so I'm guessing that in our list we don't have any lower outliers, unless colleges are really nice and they're like, tell you what, we'll pay you $187 to come to our school. And is that happening for some of our students? They're not just paying their tuition, but they're paying them to go there? Really? Wow, congratulations, good deal. So in your situation, you would be an outlier. To find the higher quartile, right, or the boundary for the upper quartile, for the upper outliers, it would be this plus that 1.5 times the interquartile range, and I'd get anything over 6,747, which notice I actually have 2 colleges that think they're so exceptional that they deserve so much money that both of those values are outliers. Wow. Yeah, so that is unusual. So yeah, it says name any outliers. Those are the 2 that I did select. All right, so now for part D, it says make a box and whisker plot of the data. So let's see, let me actually copy this whole thing. And I'll, let's see, what is that, part D? Yeah, sure, something like. So here's the data that I'm working with. So when I make a box and whisker plot, I have a single number line, right? And let's see, my lowest value is like 1900. My highest value, is much higher. Maybe I'll count by thousands. 2,000, 3,000, 4,000, 5,000, 6,000, 7,000, 8,000, 9,000, 10,000. I don't know if I'll even fit the outliers in this. I'll try. 11, 12, 13, 14, 15. You'll have to pretend. And then 16, 17, 18, 19, 20, 21, 22. All right, so here's the 20. All right, so to graph this or plot this information, my first point is going to be my lowest value, 1988. So that's going to be, if this is 2000, it's going to be somewhere right here. So that's the end of the whisker or the hinge, right? I've got Q1 at 2414. So here's 2000, here's 3000. So quartile 1 would be right there. Quartile 2, or the median, is 2838. Wow, so that's actually right there. It's less than that. Wow, that's really, really clustered. 4,147 is quartile 3. So here's 5,000. So a little over 4 grand is right there. So this is my box. I can draw my first whisker. Let's see. Now, since I have these outliers, this 5,832 will actually be the kind of the upper end of my whisker here. So 5,832, here's 6,000, so the whisker would be right there-ish. And then I actually will plot those other points, so 20,000 and 21,900. So when I put this on scale, you can really see how the 1% live their lives here with just like ridiculous. I mean, this is so much of an outlier, it's absurd. You know, it's just like ridiculous how this all lands. So remember that what this means is that 25% of my data lies in each of these zones. All right, in theory. The outliers kind of screw that up a little bit. So that means most of my colleges, it looks like the most densely populated zone is right here between these two values. All right, so most colleges back in the late 1990s, their tuition and fees were somewhere between 2,400 and 2,800, right? So that's kind of what you would see. So this is a visual representation of the density of my data, right? It's how is it distributed, how does it vary, right, is kind of what's going on. So that does take a bit of work to get one of those all together. Let's see, E, what is the mean deviation of the data? Hooray! So here we go. So I'm going to copy this list. I think it's going to copy these colors as well. And now I'm going to paste it in my little mean deviation calculator. Dun, 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 dun. Right, I've got my friends hanging out here. Oh, there's some names. I don't think they could be visible on the Excel though. Don't worry. It's okay. It's okay. Let's see. Let's grab a nice snapshot. Oh. Let's see. I'll start the snapshot from down here. Aha! You jumped out of it. You were scared. You got scared there. Let's see. So E, what is the mean deviation? Oh, wrong color. And let's see if I can scale this up enough for our online viewers. I know it gains some blur in the process, but well, that's fine. So to find the mean deviation, here's my list. I already had it in order. I had 19 colleges, right? We already knew that. The mean, all right, average mean value was 4,969, which notice, what's interesting is that 4,969 is actually beyond the quartile 3. It's actually, the average value is bigger than quartile 3. Actually, like these top 2 colleges are more money than I think like this many colleges likely. Maybe not all of them, but if I add them all up, I could actually see that. That's how ridiculous these are, and they're pulling up my mean significantly. So I find the differences for all of these. So most of them are far below the mean, and then I've got 3 of them that are above the mean, and some of them by a lot. So then I find the absolute values of those differences, and I get distances, and then I average those distances, and you can see 3,507 is the mean deviation. Which, if the mean is this, I just want to point out the mean deviation is greater or almost as big as the mean itself, right? So I just want to point out, like, this data is very dispersed, which we can't actually answer question F just yet because I didn't teach you that. We're doing that today. But discuss the variability of the data. I would say for part G, based on, let's see, I got words going together, on the box and whisker. the presence of outliers, and a high mean deviation. The data is very, or at least some of the data, I guess, is very spread out. Data is very spread out. Right. So that's my description of the variability of the data. Let's see. What did do I have the book's description on this? 23. Oh, the book said the data in the upper quartile is diverse. Right? Yeah, that makes sense. That's probably more specific. Right? You can see the upper quartile is more spread out than all 3 other quartiles combined. Probably by like a factor of 1, 2, 3, almost 4 times, I'd say, based on those values. So yeah, so that's what this mean deviation tries to quantify in a single number. How varied is our data? All right. So thanks for watching, Internet friends. Have a great day. Bye-bye.